Now?
All right, for the next talk, we have Richard telling us everything about how we finally fix full disk encryption. Let's welcome Richard.
Right, thank you very much. So, teeny bit about me. I'm a distribution architect at SUSE. I've been doing this open source stuff for way too long. I think I figured out today this is my 13th FOSDEM. The other 12 went fine, so I guess this is the one where everything's going to go wrong. And yeah, been working at SUSE for 10 years, and I created this distribution called Aeon, which I will talk a little bit about, and then show how we've done full disk encryption with all of the systemd toolchain on top of that, and then talk about some of the rough edges we have left. And then the whole plan was to have a nice Q&A open floor discussion with a handheld microphone, which of course we haven't got in this room, so I'm just going to try and figure out a way of making that work with me copying everyone's questions for the recording. So Aeon, I have a talk about this in the distro room this afternoon, but basically, in a nutshell, it's another one of these immutable desktop concepts, being reliable, predictable, immutable, a bit like microOS on the server side of things, but also being really opinionated, because this is my desktop and my daily driver, so GNOME only, very Chromebook-like experience, image-based installation, keeping it pretty minimal for everybody else, but functional. All the printing and gaming development stuff should just work out of the box. This was freshly installed last week, and the presentation's working without me doing anything on it, so that's all good. And because really, we don't want people having to mess around with lots of funky configuration to get the whole thing to work, and that includes also full disk encryption. So, last year, July, we did release candidate 3, which was the one where we put FDE in there, and it's enabled by default. In fact, you can't turn it off. If you're installing Aeon, you are getting full disk encryption if you like it or not. By default, if your hardware supports it, it's TPM backed and automatically unlocking. And if your hardware doesn't, we have this concept of a fallback mode where you've got to put a passphrase in, and you're unlocking it sort of old-fashioned Lux way every time it boots up. It's deployed calling it with a tool called Tick, basically a whole new installer that I wrote because I felt like playing around with that kind of thing. Really nothing more than it's a fancy graphical wrapper around systemd repart. So systemd repart is actually doing all the hard work, deploying the image, setting up the partitions, configuring the encryption, doing all the Lux stuff. Like everything that's remotely important gets done by systemd repart, and then all of the TPM measurements. And because this is a SUSE-style distribution, all the stitching with BTRFS subvolumes is done by a tool we have called sdbootutil. So when you are deploying Aeon with Tick, first, or in fact any distribution with Tick, but Aeon is the only one using it right now, we probe the system to figure out, does it have policy authorized NV, because that's what you need to do to get it working with PCR lock. Then also checks for secure boot, and then figures out what the heck is it going to do with those two different full disk encryption modes. Are you going to get a nice, decent, validated supply boot chain where it's actually only going to unlock if your boot chain is good, or are you just going to be shoving in a password? So if you have a good enough bit of hardware with policy auth NV in your TPM, you get default mode. Pretty much in any other case, you get fallback mode. And if you're on a machine that doesn't have good enough hardware and you've turned off secure boot, you get fallback mode with a grumpy warning. Because, okay, secure boot isn't great, but it's better than nothing. So I want to at least have people some concept of having some check of their boot chain when they're starting up their system. But typically speaking, on a default mode, I don't care with Aeon if secure boot is on or off. I just care whatever you've picked stays the same because I'm measuring PCR7. Like I said, Tick avoids doing as much complicated work as it can itself. So because of these two different modes, because I'm doing TPM backed and traditional full disk encryption with passphrases, it means I can't use systemd repart's instant TPM pairing. So systemd repart's using a key file, so I have Tick generate the key file. And then basically I just take an image, read the systemd repart config from that image and slap it on the disk you've chosen as part of the install. Simple, easy, works. The typical systemd repart config we're using is also incredibly simple, easy, straightforward. Like a rather large EFI partition on purpose, because I'm kind of expecting to move to UKIs one day. So I'd much rather make every of my current, one of the reasons with Aeon, I'm talking about this later, is like we're on RC3 as I kept on changing how big everybody's partitions were. Like this way, I'm not going to have to do that again. I think I'm probably fine with 4 gig for a while. And then everything else, I just take over the entire disk, copying the blocks from the image and encrypting that with the key file. And then after the image is deployed, there's a little bit of stitching to be done. You know, of course, the image is being built in OBS. I have had some experimental ones built with MKOSI. The current one is actually using Kiwi just because I know Kiwi better. I'm going to go back to the MKOSI one soon. But either way, it's a generic image, and of course, your system, you know, isn't a generic system. So there's a bit of stitching required, you know, correcting the FS tab to actually include the UIDs of the partition that's just deployed, correcting the command line, populating the crypt tab, that kind of stuff, and then using FDBoot util to actually put systemd boot in the ESP and the kernels in the inrd, because we're not using UKI, so it's just putting all of that stuff in there separated. Then in default mode, there's a couple of extra steps because we're doing all this TPM pairing, so we configure our PCR policy, which I'll talk about a bit more later, and then update those predictions for the system and enroll it into the TPM. So systemd FDBoot util just reads that config and figures out the entries for every PCR I'm interested in, and then systemd decrypt enroll nicely, simply pairs it all up, and away we go. And in fallback mode, of course, none of that TPM stuff needed. You just ask the user for a passphrase. I decided when I was doing this that kind of, you know, for in a TPM environment, you know, if your TPM breaks or your measurements don't match up, you know, you need to have a recovery key to get into the system and unlock it manually. And for fallback mode as well, you know, I also kind of figured, you know, users can be silly sometimes and forget their own password. So generating a recovery key for everybody in every case all the time, and then presenting it to them with a nice long string and a nice QR code that you can store on your phone or whatever to remember what's going on. And then last but definitely not least, wiping that key file that it used for the, to get the whole thing running. So the only keys that are enrolled in the end are your passphrase or the recovery key or the TPM. And that's been how every single Aeon user, including myself, has been running their laptops since July. And to be honest, it's been mostly painless. It's just working. FDBoot util is doing a wonderful job of every time there's a system update, updating all of the predictions. Of course, we also have automatic rollbacks and failure detection, and of course, systemd boot util is aware of that too, so it'll even update the predictions when you roll back from user space, which is really nice. As I talk about in a bit, we did mess around with the PCR policy a bit, so I did have to make a little tool to go and check everybody's machine to fix which PCRs are being checked. But besides that, it's mostly just working. But not 100% perfect. So the first thing we had issues with is this lovely recovery key. I don't know if this is just an FDBoot util thing or also with systemd decrypt enroll. But there's a whole bunch of effort taken to only use characters which are all in the same location on everybody's keyboard, which is awesome. So, you know, German keyboard, I've got a German keyboard here, but I type in English. It's great. These French, whatever, the character set is ridiculously constrained, so it's just the keys that don't move around on all these different keyboard layouts. Brilliant work. Does make the string a little bit longer because you still want to have some entropy. That's fine. But we're using dash as the separator, and that's the one key that moves on every single keyboard layout.
You can drop the dashes.
I can?
They have no value.
They have no value? They do nothing?
Just
When I drop the dashes, it fails for me. I'm doing something wrong.
Well, yeah, you have to use the system tools to do this because they will drop the dashes. If you use the tools,
Okay.
type in with the dashes, it will consider that a password and
Yeah.
not do this.
Okay.
But, yeah, you can type it in uppercase and lowercase and drop the dashes.
So that's awesome. My own implementation is the problem, which is perfect. Thank you very much. Yes.
Just use like points, dots instead of dashes.
Well, I was going to just use spaces or something. Yeah, the question was why don't I just use points or something? I could just use spaces. I could also just do what systemd is doing with their tooling.
We
So
can revisit that.
Yeah.
Like if there's
It's-
better characters separate, it doesn't really matter.
I know it's a little thing, but it's the one that my users have hit so many times, and it's like if this is the biggest problem we have, really, FDE is really doing well, but this is the biggest problem we have.
Exactly the same.
Yeah. The question was why can't you just have your native keyboard layout running? We're very early in the boot process here. You haven't unlocked your disk yet, so you've only got what you've got in your ESP. Yeah, but when you type your key, you've generated your key, so you've stored that key in whatever keyboard layout you've done, so that's all fine. In this case, this has been randomly generated by us, so if there's a mismatch, then yeah. One thing I would really, really like is multi-factor authentication, but the only option we have for that right now is TPM and PIN, and TPM and PIN is scary, not for anything that we control in software, because we don't control that. That's really what the manufacturers do, and the other problem we have had with this has been how different manufacturers with different firmwares do things somewhat subtly differently, and suddenly I have someone's machine that the TPM just doesn't want to respond anymore, and the thing never unlocks. So, yeah, the kind of open question is: are we really stuck with just
I know exactly what we need to do for the TPM FIDO stuff, which is what the Chromebooks do. It's just somebody needs to implement that.
So what do the Chromebooks do?
They do it really nicely because the TPM basically asks a challenge to the FIDO thing. The FIDO does the regular FIDO stuff like what it always does, like signing something. And then the TPM gets the signature back, right?
Yeah.
And then it will release the encryption key to the...
And that would all be in addition to all the other PCR checks that have done.
It's a comment.
So the comment was basically doing what the Chromebooks do. So having the TPM challenge and the FIDO key separately, and then unlocking only when both pass. So
I know exactly what to do. It's
Yeah.
a matter of implementing.
that's fine. That's good. I'd like that, and maybe I will find time to do it, but maybe not. So yes, our PCR policy, we started initially following what OpenSUSE and MicroOS was doing, which is PCRs 0, 4, 5, 7, and 9. Well, actually, 5 I think I might have added, but 4, 7, 9, and 0 for sure. Which of course was great, apart from every time somebody did a firmware update, then PCR 0 no longer matched because you've just changed your firmware. And of course with Aeon, it's a desktop OS. I have FW update there with GNOME software, and it was running all the time. Reading the system decrypt setup docs are a good starting point. It's recommended there to not measure PCR 0 for this kind of reason, so I'm not measuring PCR 0 for this kind of reason anymore. But I do always ask myself, is this enough? And of course I wrote this slide 3 weeks ago, and now there's a nice blog post that's telling me definitely, probably not enough. There is cases like potentially, with a really strong way. Basically the kind of potential bypass here is, some very fancy person could theoretically inject a different operating system kind of in front of your one. So, potentially you could end up booting into a different environment than you were expecting, but that environment still gets the keys unlocked, so it can still read your disk. Really, the recommendation there is to, measure PCR 15. systemd has all this wonderful tooling for measuring lots of file system information and UUIDs and recovery keys and all that stuff, and none of all that stuff only works if I'm using systemd stub with UKIs. Is that really the one true way for... Why
don't you want to use the UKIs?
Yeah. Yes, fine. Well, the reason we haven't used UKIs up to now with Aeon is, of course, we're using BTRFS with our SUSE-style fancy snapshotting and rollback. So every update to the system creates a new BTRFS snapshot. The main magic with SDBootUtil is basically creating boot entries in system deboot. So when your system no longer boots, you can pick a different boot entry to go to.
That's not a reason to say no to UKIs. That's the reason why you want type 1 entries, right? So my suggestion would always, like, you can use a type 1 SDBoot, like a BLS entry, pointed to a UKI. So you basically...
Yeah, so the answer was, you could just have a type 1 entry pointed to a UKI, but that UKI has a command line that, is signed, checked, etc. And with our snapshots, we are typically changing the snapshot by changing that command line to point to the different snapshot number, which,
Yeah, but
What about using UKI profiles?
what's it?
they can't do this. No,
Yeah, we can't use UKI profiles. We looked at. I actually have an idea that I came up with while writing these slides, which would basically just be creating a directory structure, on my system for each UKI version that I know the system's deployed. So, UKI version 1 points to this snapshot, and that's contained in the OS. So therefore, when it boots, fine. And then that means in user space, I can do all the fancy rollbacks to whatever snapshot I want, and at boot time I just have a list of UKIs, which would be simple and easy, and actually probably more sensible for our users, because most of the time when you're using that boot menu, you're only trying to recover because your kernel's messed up, so booting to a slightly older snapshot with the same kernel is actually the worst thing.
You consider using credentials to control your snapshot, because you can seal them against your local TPM, given you're creating them locally.
I had
The credential in the USP and use that.
I had no idea we could do that. That's a cool idea. So the question, the suggestion was like, why don't we use credentials with? Yeah, that's an awesome idea. I'll look into that.
I mean, this is the use case for system credentials, right? Like that you put them locked to the TPM next to the kernel. Now, in your case, it's not going to work one-to-one because you only want one kernel with 500 boot menu entries after all. Right?
Yep.
So we would probably there's a issue open already about something like this where you you actually can use the global credential. Like we have a directory for global credentials. You can just stuff your you need the other way around. Anyway, but there's a discussion going on precisely about your problem on GitHub issue, and I think it's really easy that you take a BLS1 thing that points to the UKI, but then also we teach BLS type 1 to point to a credential file, right? So, and then for every BTRFS snapshot that you have, you generate one credential, which has the authenticated information, and then one BLS1 entry that glues it together with the UKI.
Yep.
That itself is not authenticated, but that's not a problem.
So that's all that answer's sorted then. So.
Expecting a patch from them.
Yes, you can definitely get a patch from me. I will definitely be looking at that. That seems to... So that's actually my topics. So does anybody have any questions or any more feedback? Although I think we covered the burning topics already. Yes?
So I wonder if we should go away from always mentioning like the non-TPM thing as the fallback path, at least for desktop systems. Doesn't it make more sense for the FIDO stuff to be the primary thing and then the TPM be the add-on to that instead of focusing so much on the TPM and then like the phosphate or whatever being the fallback?
So the suggestion was like, why do the TPM as the default and not passphrases as the fallback? My logic with that is really, in the case of Aeon, being partly because I'm lazy, I just want my laptop to boot. I don't want to actually enter a passphrase. Ideally I want to know that I'm booting, the boot chain that I should be. So I'm using FDE with TPM to really give me that verification that my system is good, and I'm not interested in having a passphrase to unlock my machine. So that's the mindset there.
Passphrase somewhere, right? Because otherwise, if someone else fixes your machine,
login time.
Yeah, at login, and of course the nice thing with all of this, because of stuff like the command line being validated, then I know no one's going in and changing, boot to bin bash and doing silly stuff like that. So my Linux actual login passphrase is suddenly actually meaningful. So I rely on that to do my data. So that's that's the mindset switch that I've done with that, and that's kind of where it's reflected with that. I get, like, the traditional way is thinking the other way around, but, like, then if I do, then I lose all of my checking of my entire boot chain. Like, that's what I want this for. Like, yeah. So that's the logic. Yes. If someone steals your laptop, I'm relying on your Linux authentication to actually work and not be easily bypassed, because you can't easily bypass it because you can't go and do stuff like changing your CMD. So yeah, totally different approach. I get it. I know that freaks some people out, but I'm happy with that. But with that caveat of, like, the command line checking really has to be good. Yeah. Any more questions?
5 more minutes.
Yeah, got 5 more minutes. Yes.
Maybe for recovery keys being more friendly, we could use the camera, but I don't know if that's possible, so that you can show the QR code for
So the suggestion was, using the camera on boot to read the QR code from your phone for the recovery key. I mean, I like that idea. I don't think I'm going to get away with putting a camera driver into system deboot, maybe. Yeah. Like, that's a lot of, like, how do you show that to the user so they know where to hold the phone? Like, so then you need like Wayland in system deboot.
And that could be doable.
Yeah, actually, if you've been...
With the UKIs from packages, then we just need to pull in the right packages for that. And it's a little bit low.
Because I really like this idea, because when I was talking about site attendees, one example I gave is having a user who needs audio to actually be able to use the machine, so we need to put the audio stack in the ID, which means that we need to put the Bluetooth stuff in the ID. And having a camera is just a small addition, and I think it's just coming. So that's a very nice idea.
Yeah, Linux hello. Just have the camera check at your face. Yeah.
Sure. One thing I wanted to mention is that if we do the FIDO thing with the TPM stuff, I think something else we can do is like a TOTP thing against the TPM. Right?
Yep.
So and that would make the key so much shorter, right? Like,
Yeah.
But we could just integrate that with the regular TOTP app that everybody has.
Yeah.
So somewhere on my to-do list, more so than FIDO to support with TPM at the same time as to just do TOTP.
TOTP with that would be I mean, when it comes to multi-factor, I'd like to have more options than just relying on the TPM.
The TOTP thing has a really nice thing that all the cell phone operating systems have nice apps for that.
Yeah.
While the PCR, like the QR code that we currently show, it's fucking text string.
Yeah. Yeah,
it's gonna consume that even.
No, it's not great, but it's better than nothing, and yeah.
Any more questions?
Yeah. Do you support having multiple factors in combination? So FIDO key plus something?
No, that's kind of what we're talking about. Like I'd yeah.
That's an interesting question. It always comes up. People want to use like SSS, like the Samia's secret sharing scheme. I think that would be weaker model actually than what the FIDO 2 plus TPM stuff that the Chrome OS people are doing, because if you use SSSS and then combine this in user space, the keys that you get from the individual hardware, then this is all done in user space, right? Like,
so there's no way to do it in the TPM.
I don't think you can.
No, and that's yeah.
No. The next best thing is it's much nicer than if for the FIDO 2 to TPM stuff there is no all the calculations are done on the TPM and the FIDO device, and only when everything checks out the TPM will release the volume key to you, and that's a really nice model.
One last comment. As soon as that guy merges my IPRs, MKUSI and the command
Yep.
on OBS, you'll be able to build UKIs for Aeon and sign them on OBS with the PCR stuff signed as well.
That's-
the double sign.
that's-
Last week.
As of last week, so that's
MLS merged my PR on the back end, so that now works.
perfect. So yeah. So even if I'm stuck on doing UKIs, it's going to be easy. That's awesome news. Thank you. Great.
Okay. Yes, I think we're out of time, so let's thank Richard.